Okay, the next speaker is Chow, and his presentation is the kernel reading is
Good morning, everybody. In this presentation, I will talk about internal reading and reciprocity. In English, sentences with each other have been treated as the canonical reciprocal expression. However, apart from each other, some other sentences also carry a reciprocal meaning. A typical example is this sentence with the same. This sentence is ambiguous with two readings. Under the deictic reading, it is uttered under a context like Susan read Robinson Crusoe and Treasure Island last summer. And so this sentence means John, Peter, and Mary read Robinson Crusoe and Treasure Island. Under the internal reading, this sentence means any two of John, Peter, and Mary read the same books that are not necessarily salient in the context, and is equivalent to this sentence with each other. What I am interested in this presentation is the internal reading. In addition to the same, some other lexical items behave similarly in that a sentence containing one of these lexical items also has an internal reading carrying a reciprocal meaning. These items will be called reciprocal items and include the same, different, opposite, similar, related, separate, adjacent, complementary, connected, disjoint, etc., etc. The reciprocal meaning of these reciprocal items can be illustrated by this sentence, which sounds weird under the internal reading. The intended meaning of this sentence is particles 1 and 2 have different charges, particles 2 and 3 have different charges, and particles 3 and 1 have different charges. But this is impossible because there are only different charges. Another evidence for the reciprocal meaning of these reciprocal items is that most of them can be rendered in Chinese as words with the morpheme xiang or hu, meaning mutual. For example, the same can be rendered in Chinese as xiangtong with xiang, and complementary can be rendered as hu with hu. From this table, you can see that the Chinese renditions of all these items contain the morpheme xiang or hu, although these may not be the most colloquial Chinese renditions. The main purpose of this presentation is to provide a uniform formal treatment for the internal reading of the reciprocal items using the generalized quantifier theory, GQT, enriched by the notion of generalized noun phrases, GNPs. According to GQT, a generalized quantifier, GQ, is a function that requires a number of predicates as input and output a truth value. For example, every is a function that requires two unary predicates as input and output a truth value, and so its type is denoted 1, 1. The notion of GNP is a generalization of GQ. Instead of outputting a truth value, a GNP outputs a set or a characteristic function of ordered n tuples of individuals or type 1 GQs. According to Suba, each other should be treated as a GNP with this denotation. Note that this is a type 1, this is a type 2 colon bracket 1 GNP because it requires a binary predicate R as input and output a set of type 1 GQs. This diagram illustrates the difference between GQs and GNPs. In the left tree diagram, if somebody is an ordinary VP with type ET, it serves as the argument of the type 1 GQ everybody. To yield the type ET, the polymorphic GQ somebody here acts as an arity reducer, which reduces the arity of the binary predicate kit to get a unary predicate kit somebody. And so the type of somebody in this case is EET. In the right tree diagram, hit each other is a raised VP with type ETTT as proposed by Suba. It serves as a function of which everybody is its argument. To yield the type ETTT, each other has to be a function with type EET, or in other words, a type 2:(1) GNP. Here is an example of a sentence with each other. This sentence can be denoted by this expression. By using the denotation of each other given above, one can show that this expression is true if and only if any two of John, Peter, and Mary stand in the relation of Kit, which is exactly what this sentence means. I next propose that the internal reading of the reciprocal items should also be treated using the GNP each other. Consider this sentence again. I propose to denote this sentence by this expression, where Q should be the type 1 GQ denoting John, Peter, and Mary, while R should be a binary relation denoting read the same book as. Now the question is how to determine this binary predicate. To answer the opposite question, we may draw reference from Bengal's study on structured quantifiers. According to Bengali, this sentence contains a type 1 square GQ, the same as with this denotation, where the same is a logical term with this definition. By using this type 1 square GQ, we can denote this sentence by this expression, which gives us the correct truth condition of this sentence. Notice that this phrase also contains the same as, which appears in the second argument position of read. According to Suba, although the same as here cannot be seen as a GQ, it can be treated as a generalized comparative determiner, which is a subtype of GNPs. In this presentation, I will modify Suba's theory a bit and propose to treat the same as here as a type 1,2:2 GNP with this denotation. The subscript 2 here represents the fact that the noun modified by the same appears in the second argument position. Note that the variable W representing that noun does appear in the second argument position of the binary predicate R. Also note that this function is of type 1,2:2 because it requires a unary predicate P and a binary predicate R as input and outputs a set of ordered pairs. With the same as subscript 2, we can denote this expression by, we can denote this phrase by this expression. We can now write down the denotation of this sentence, this expression, by using the denotations of each other and the same as subscript 2 given above. We can determine that this expression is true if and only if any two of John, Peter, and Mary are such that the books that one read are the same as the books that the other read, which is exactly what this sentence means. In Suber's paper, there are other type 1,2:2 GNPs, such as these. According to Suber, all these GNPs satisfy a property called argument invariance for unary determinants, D1AI, which can be seen as the defining property of such kind of GNPs. Here is the modified definition of D1AI. I propose that all the reciprocal items should be treated as type 1,2:2 GNPs like these. In this way, we can greatly expand the inventory of type 1,2:2 GNPs first studied by Suber. Justification for this treatment is that all these GNPs satisfy D1AI. For example, this is the denotation of separate from subscript 2, where separate is a non-logical term. With the epithet separate from subscript 2, we can write down the denotation of this sentence as this expression, which is true if and only if any two of John, Peter, and Mary are such that the floor on which one lives is separate from the floor on which the other lives, which is exactly what this sentence means. The GNP each other introduced above is only applicable to cases where Q is an upward monotonic GQ. To cater for downward monotonic and non-monotonic GQs, I propose to modify the denotation of each other as this expression, which contains this disjunct and this conjunct. Notice that this disjunct is to handle cases which do not require a witness set, while this conjunct is to count the number of individuals that enter into a mutual R relation. It can be shown that the modified version of each other reduces to the original version if Q is non-tautological upward monotonic. With the modified version of each other, we can now handle sentences with downward monotonic and non-monotonic GQs. For example, these two sentences with nobody and exactly 3 persons can now be denoted by these two expressions. One can find that these two expressions give us the correct true conditions of these two sentences. I next discuss how to modify the formal framework discussed above to cover several types of sentences which are different from the sentences discussed above. The first type of sentences are those with a weaker reciprocal relation, such as this one, which contains adjacent. To illustrate the idea in a simpler and clearer way, I will consider this sentence instead. Now, this sentence can be represented by this diagram, which shows that 3 persons cannot be adjacent to each other in the sense of each other given above. Because if John is adjacent to Peter, and Peter is adjacent to Mary, then John cannot be adjacent to Mary unless they are standing in a circle. To handle this case, we can adopt a weaker version of each other, like this, where R plus represents the transitive closure of R. That is the smallest transitive relation containing R. With this diagram, we can then write down adjacent star to be this set and adjacent plus star to be this set. If we choose X to be this set, then we can find that this expression is not satisfied while this one is satisfied. And this shows that R plus gives us the correct denotation of each other when we have a binary predicate denoting a weaker reciprocal relation like adjacent. The second type of sentences are those in which the reciprocal items appear in the syntactic position other than object, such as this one, where the same appears in the first argument, i.e. subject position. To handle this case, we can change the same as subscript 2 to the same as subscript 1 with this denotation. The subscript 1 here represents the fact that the noun modified by the same appears in the first argument position. Note that the variable W representing that noun does appear in the first argument position of the binary predicate R. With the same as subscript 1, we can write down the denotation of this sentence as this expression, which is true if and only if any two of John, Peter, and Mary are such that the waiter who served one is the same as the waiter who served the other, which is exactly what this sentence means. The third type of sentences are those with more than one reciprocal items, such as this one, which contains both the same and different. For simplicity, here I assume a weak version of different, which is just the negation of the same. To handle this case, we can first write down the denotation of the phrase read the same books as and read different magazines than as this expression. Note that this expression contains two occurrences of read, which is different from the original sentence. To remedy this case, we can make use of lambda abstraction to abstract out read to obtain a function and then apply the function back to read. In this way, we can obtain an expression which contains only one occurrence of read. By following the remaining steps as usual, we can then obtain this expression, which gives us the correct truth condition of this sentence. In the formal framework introduced above, I have been explicitly using the GNP each other. However, the surface syntactic structure of this sentence does not include each other. And so, to further refine my formal framework to make it more in line with the surface syntactic structure, I now propose to introduce a new GNP called internal the same subscript 2 with this denotation. Note that this is the type 1,2 colon bracket 1 GNP because it requires a unary predicate P and a binary predicate R as input and outputs a set of type 1 GQs. With internal the same subscript 2, we can now write down the denotation of this sentence as this expression. Note that this expression does not include each other, and so it is in line with the surface syntactic structure of this sentence. Moreover, by applying the denotation of internal the same subscript tool, we can obtain this expression, which gives us the correct truth condition of this sentence. And that's all for my presentation today. Thank you for listening.
Thank you for the talk. Could you go back to the previous slide? The last slide.
Let me see. How?
No, the last slide before thank you.
Oh, let me find it. This one?
Yeah, I think this one. So based on the prediction of this analysis, I kind of feel like the truth condition might be both too weak and too strong. So I think that the analysis predicts that the sentence John, Peter, and Mary read the same books would be true if like John and Peter read the same book, right? John and Peter read Anna Karenina. Peter and Mary read Harry Potter. Mary and John read War and Peace because each of the two people among them share the same book. But I think that in that case, we intuitively would judge this sentence false. John, Peter, and Mary read the same books. On the other hand, if John, Peter, and Mary, all of these three people read Harry Potter, and in addition, each one read some other books, we will still judge this sentence true. John, Peter, and Mary read the same books.
In fact, what I think about the truth condition of this sentence is I adopt an exhaustive interpretation of the sentence, and so the same here means that the books that the three persons read are the same, exactly the same, and they do not include other additional books.
I see.
Yeah. Right? There may be other non-exhaustive interpretation, but what I'm considering is the exhaustive interpretation because because my theory is based on Becker's interpretation of the same as, and Becker's truth condition for the same as adopts an exhaustive interpretation.
I see. So I think that native speakers' intuition for the interpretation of same here might not always be exhaustive, especially like the use of the definite determinant the in this case is a bit special, because usually we cannot say there is the dog, but I heard that in the literature people have reported that sentences like there are the same people on the beach. That kind of sentence would be good. So maybe the use of the here does not indicate exhaustivity. Thank you.
Any other questions?
Okay, thank you very much. It's interesting for your analysis is interesting that the same or expression like the same is based on each other, right? And so my question is sentence like few people read the same books. How would you analyze?
Few people read the same book, and so we have to use few. Do you mean it is a downward monotonic? That's right. And so each other associated with same here has to be the each other which can cater for downward monotonic review. That is this one. That is this one. The each other here is okay. This one. this denotation for each other is to cater for all kinds of type 1 GQ. And so if the sentence is few people read the same book, then each other in the meaning of associated with the same has to be this each other, this version of each other. In fact, this is the most general version of each other. But in the presentation, I usually use the not so general version just for convenience. So in a general case, we have to use this general version.
Few people as a generous quantifier doesn't have a witness set. Witness. So there is no common in the denotation of the few people as a generous quantifier don't have a how do you say, don't have a set which contains any individual.
Or do you mean the bigger set?
That's right. The smallest set common in the denotation. So I don't understand that. So in the case of few people, there is no actual individuals. You can distribute the property of reading the same books. So what is the interpretation of few people read the same book?
But I think even with the field, which is a downward monotonicity field, there should also be a witness set. A witness set, if it's empty, then it can be taken care by this stuff. It contains two possibilities. One possibility is that few denote the no. Few contains the case no people, and if no people, then we use this jump. But in some cases, few can denote some people, a very small number of people. And in this case, we still need a witness set. And so that's why this denotation contains such a disjunct here. This disjunct is to handle the case which does not require a witness set.
Okay, I'm not so sure I understand it, but we can talk about it later. Okay, thank you very much.
Okay.
Thank you. Sorry. Thanks very much for your talk. Looking at the analysis you give, you're treating each other as a primitive operator here.
Yes.
I wonder if you have any ideas about how, could you give a more fine-grained analysis where each and other are contributing to the overall denotation that you're giving? Of each other.
Each.
For the condition of each other,
Yeah. Or would you want to treat each other as a primitive? Always.
I treat each other as one unit.
Yeah.
One
But
unit.
could you break them apart?
I haven't thought about this.
Because I mean the reason why I ask is because English also has one another, which
Yeah.
basically has the same interpretation of each other. And is there anything to kind of really connect those two in terms of?
In fact, I treat each other and one another as synonyms. They have the same denotations.
Yeah.
Of course,
I think that's correct, but is there kind of some compositional story you give about why they're the same?
for the time being, I cannot do that. This requires further. I think this requires further study, further research.
Yeah, thanks very much.
Okay, thank you. Thank you.